All right, here's our review of slope and slope-intercept form. We are talking about slope-intercept form and graphing linear equations. And our main equation and formula is going to be y equals mx plus b. And we have two main components here, where m is our slope and b is our y-intercept. Hopefully, everyone watching this can remember seeing this in Algebra 1. So this should be a review of sorts. Using y equals mx plus b, if we have a linear equation that is already in this form, we can graph this equation by identifying the y-intercept, which is our b value. In this case, b is -1, and identifying the slope, which is the m value in our equation. The slope in this equation is -2/3. Following the process outlined by the bullet points, identify the y-intercept. We're going to plot the y-intercept. So I find my y-axis starting at the origin of 0, 0. I go down where y is -1. And now I'm going to use my slope to plot other points on this line. So putting my pen on the y-intercept, we're going to use the slope, thinking about this idea of rise over run. So the top value is how much I'm going up or down, and the bottom value is how much I'm going left or right. In this case, we have a negative, so I'm going to attach the negative to the 2 on the top. So we're going to go down 2 and then to the right 3 and put a dot. Down 2 to the right 3. Down 2 to the right 3. And I found 3 other points on our line. Now I can also reverse it and go to the left to find other points on my line going this way. So going back to the y-intercept, I can go up 2 and to the left 3, up 2 to the left 3, up 2 to the left 3. So I found a bunch of points on this line, and I can connect them to complete the graph. All right. The second way we're going to look at graphing linear equations in this video is by using the x and y intercepts. In this example, I have an equation that is not in y equals mx plus b form. Our equation here is 6y equals 3x plus 6. So if I remind myself y equals mx plus b, I can't see the slope and the y-intercept right away because it's not in the same form. So we're going to use a different method. We're going to identify the y-intercept and the x-intercept and graph it using these 2 points. Identifying the y-intercept, another interesting fact about the y-intercept, it's a special point because it's always on the y-axis here. And because no matter what equation we're dealing with, if we're talking about a y-intercept, it's always on the y-axis. That means that x is always going to be 0. So that allows us to plug in a 0 for x into our equation here and solve for y. So I'm going to rewrite my equation, substituting a 0 for x. And now I can solve for y. 3 times 0 is 0, plus 6 is 6. If 6y equals 6, I can solve for y by dividing both sides by 6, which tells me that my y-intercept equals 1. So I'm going to graph this one in red and put a dot here. Okay. So I'm going to bold my x-axis here. And we're going to use the same idea to solve for the x-intercept. The x-intercept is always going to be on the x-axis. Therefore, I know when I'm looking for the x-intercept, my y value is going to be 0. So I'm going to plug in a 0 for y and solve for x. So that tells me, I'm going to do my work down here. 6 times 0 equals 3x plus 6. Substitute in for y. Now we're going to simplify and solve for x. 6 times 0 is 0. 2 more steps to get x by itself. We're going to subtract 6 from both sides. Negative 6 equals 3x. Divide both sides by 3. And my x-intercept is negative 2. So I'm going to go back up to my graph. I'm going to plot my x-intercept, negative 2. We're going to connect these two, and there's our line. Graphing a linear equation using the intercepts. Okay, one more example, graphing using the intercepts. I'm going to go a little quicker on this one. 8y plus 2x equals 16. I'm going to start by finding the y-intercept. So I'm going to remind myself that x equals 0 when I'm looking for the y-intercept. So 8y plus 2 times 0 equals 16. 2 times 0 is 0. So that tells me that 8y equals 16. Can divide both sides by 8. 16 divided by 8 is 2. So there's my y-intercept. Solving for the x-intercept. I'm going to remind myself that y equals 0 when I'm looking for the x-intercept. So we're going to plug in a 0 for y. 8 times 0 plus 2x equals 16. That tells me that 2x equals 16. Solve for x. We're going to divide both sides by 2. My x-intercept is a positive 8. Going over to my graph. 2, 4, 6, and 8. 4, 6, 8. There's my x-intercept. Connect the two lines. Complete our graph. All right. Now, between the two methods, you may eventually decide that you like one more than the other. And I feel like most people would prefer to graph using the slope-intercept method. Um, it's a little shorter, a little less calculations. So if we prefer the slope-intercept method, we can manipulate the equation so we don't have to solve for both intercepts. To do that, we can follow this 4-step process. Our first step, we're going to solve for y, and then identify the y-intercept, identify the slope, and use those to graph our equation like we did in the first example. Starting with our equation here, 5x plus 2y equals 10. Our goal is to solve for y. We want to get y by itself. So if I rewrite my equation, I have to get y by itself. So I'm going to subtract 5x from both sides. 2y equals a negative 5x plus 10. And when I'm solving it, I'm writing it with the x term first on the right side because I want it to look like y equals mx plus b. While it would be correct to write 10 minus 5x, it would be the same. I want the x term first. So when I subtracted my 5x, that's why this is a negative 5x. One more step to solve for y. If 2y equals negative 5x plus 10, I want to get y by itself. We're going to divide both sides by 2. On the right side, I have to divide everything by 2. It's an easy place to make a mistake. So I have to divide both parts of the right side by 2. So we end up with 2 divided by 2 is 1. So we have y equals negative 5 over 2x. 10 divided by 2 is a positive 5. And here's our equation in y equals mx plus b form. Now that we're in y equals mx plus b, I can see the y-intercept is 5, and the slope is a negative 5 over 2. And we can use these two pieces of information to graph. I'm going to put the y-intercept on the graph, positive 5. And then starting at the y-intercept, I'm going to use the slope to find other points on the graph. We're going to go down 5, 2, 4, 5 over 2. Down 5 over 2. Down 5 over 2. We're using that idea of rise over run. Connect our points to complete the graph. One more example, changing an equation from standard form to y equals mx plus b. First step, we're going to solve for y. Subtract 3x from both sides. Okay, and I'm writing it in that shape with the x term first. Subtract 3x from both sides. Negative 2y equals negative 3x plus 4. One more step to get y by itself. We're going to divide by a negative 2. Divide everything on the right side by negative 2. We end up with y equals negative 3 divided by a negative 2. I'm going to leave it as a fraction, but a negative divided by a negative is a positive. Positive 4 divided by a negative 2 is a negative 2. Here's our equation in y equals mx plus b. My b value is negative 2, and my slope is 3 over 2. So I'm going to plot my y-intercept and use the slope, thinking about rise over run. I'm going to go up 3 over 2, up 3 over 2, up 3 over 2. And I can reverse it. I go down 3 to the left 2, down 3 to the left 2. And connect the points to complete my graph. Last two things we're going to talk about in this review section of slope and slope-intercept is a couple of special cases, horizontal and vertical lines. So we're going to see a few cases where we're given an equation, and this is a line, but there's only one variable. In this case, it says graph y equals 4, and that's it. There's no slope. There is a y-intercept. There's no x value. It just looks different. Some people might say it looks weird. So when we see something like this, it should set off a little kind of light bulb. You'll be like, wait a minute, something weird is going on here. We only have one variable, y equals 4. And we're going to start by plotting a point where y equals 4. So I'm going to go to my y-axis and put a point right here at 0, 4. Here's my y-intercept. And from here, this equation is telling us a rule. It's telling us that one thing is always true. It says y has to equal 4. Y equals 4. Y is equal to 4. And that's it. It's the only thing that matters for us graphing this equation. Y always has to be equal to 4. So I need to find another point where y equals 4. So I could put a dot here at 4, 4. As long as my y equals 4, it's meeting the requirements of this equation. So I'm going to find another point where y equals 4. And I could go over here, 2, 4, 6, 8. We could say this is negative 8, 4. My y value is still equal to 4. And I could continue doing this, plotting points where y equals 4. Okay? Anywhere along this line, y is always equal to 4. This equation is true. Connect these points to form a line. What kind of line is being formed if we connect all of the points where y equals 4? We end up with a horizontal line. One thing to note here, while we can't see the slope, this is not quite y equals mx plus b. Our m is 0. It would make sense if we thought about it, y equals mx plus b. What would happen if m equals 0? Well, 0 times any number is 0, so we'd only be left with the b. But we just want to remember dealing with a horizontal line, it's flat. The rise over run, there is no rise over run. It doesn't go up any, stays flat, has a slope of 0. Second special case, we're going to look at a vertical line. We could see an equation like this, x equals negative 3.5. Again, one variable. It should set off a little light bulb. It looks kind of weird. Where's my y value? I don't know. Let's start by graphing x equals negative 3.5. So if I go over to the graph, negative 3, and we're going to estimate in a half. Negative 3.5. Just estimating, putting it halfway between these two lines here. This is my x-intercept. Negative 3.50. Now I'm going to do the same thing I graphed for the horizontal line. Where are other points where x equals negative 3.5? I could say negative 3.54. I could say 2, 4, 6, 8. Negative 3.5, negative 8. And if I locate more and more points where x equals negative 3.5, I should see a line start to form. And if I connect all these points where x equals negative 3.5, we will see a vertical line form. In vertical lines, our slope is undefined. All right. That's our review for slope and slope-intercept form.